So now we're going to take a look at a couple of ways we can verify trig identities using some of the formulas we've done in this unit. So I have 3 examples that I want to go through in this video. First 2 are up on the board. So let's just focus our attention on this first example here, where we're going to prove the identity sine of x plus sine of y over cosine of x plus cosine of y is equal to the tangent of x plus y over 2. And I'm going to just work through this identity from left to right, start with the left-hand side and prove we can simplify it to the right-hand side using our formulas. Generally, the format of the left-hand side will tell us what formula we want to use to start out. So note we have a sine plus a sine, and we have a cosine plus a cosine. So that's an indication that we want to use a sum to product formula. So if we use a sum to product formula up top, sine of x plus sine of y is going to be 2 times the sine of x plus y over 2 times the cosine of x minus y over 2. Okay, so that is just the sum to product formula for sine plus sine. If we do the same thing on the bottom, cosine plus cosine, the sum to product formula is going to be 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. Okay, so again, these are just 2 applications of the sum to product formula. Okay, now we note that we have a 2 over 2 we can cancel. We have cosine of x minus y over 2 on the top and bottom we can cancel. So that leaves us with the sine of x plus y over 2 divided by the cosine of x plus y over 2. Okay, and now we have the sine of an angle divided by the cosine of an angle, and that's just the tangent of the angle. Okay, so indeed, the left-hand side simplifies to the tangent of x plus y over 2. Okay, so in the grand scheme of things, that is a pretty simple trig identity to prove. This next one's a little bit more complicated. So here we want to do the cosecant of alpha minus beta is equal to the cosecant of alpha times the cosecant of beta over the cotangent of beta minus the cotangent of alpha. And again, we're going to work from left to right so that the left-hand side can simplify to the right-hand side. So note first that we are taking the cosecant of a difference. We have the cosecant of alpha minus beta. We don't have a sum or difference formula for cosecant, but we can start out by using a reciprocal identity and say cosecant of alpha minus beta is 1 over the sine of alpha minus beta. And we certainly have a difference formula for sine. Okay, so we use the fact that the sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. And I'm referring to my formula sheet while I'm doing this. Note that I don't have all these committed to memory either. I'm certainly not expecting you to. So here we're going to use the difference formula for sine from the sum and difference formula video. So we use the fact that sine of alpha minus beta is sine alpha times cosine beta minus cosine alpha sine beta. So just looking at this, it may not be clear what we need to do. So it always helps to think about your right-hand side and think about what you need to do to get there. In particular, let's look at our denominators. So we want to get to cotangent beta minus cotangent alpha. What we have is sine alpha cosine beta minus cosine alpha sine beta. So in other words, what we want to do in the denominator, we want to turn this first term into a cotangent of beta. How would we do that? Well, cotangent beta is cosine beta over sine beta. So we would need to divide by sine beta. But we also need to get rid of this sine alpha, so we need to divide by sine alpha as well. So when we do that with our first term, sine alphas will go away. We'll have cosine beta over sine beta is cotangent beta. But if we look at our second term and we do cosine alpha sine beta over sine alpha sine beta, now the sine alphas cancel, and we have cosine alpha over sine alpha is cotangent alpha. So in other words, if we divide the bottom by sine alpha sine beta, and we divide the top by sine alpha sine beta, what we'll end up with, and I'll try to do this in a couple of steps so that everybody stays on board. So up top, we have 1 over sine alpha sine beta. That's the same thing as cosecant alpha times cosecant beta. Yeah, that's good. That's the numerator we wanted. So again, we're just taking the top and dividing by sine alpha sine beta. That's the same as multiplying by cosecant alpha cosecant beta. And then on the bottom, if we break this up, we have sine alpha cosine beta over sine alpha sine beta minus cosine alpha sine beta over sine alpha sine beta, sine alpha. And note that I haven't changed the term at all because we multiplied the same thing on the top and on the bottom. So that's why we can do this. So on the bottom, we have sine alpha over sine alpha. That cancels. And then over here, we have sine beta over sine beta. That cancels. Okay, so that leaves us with, up top, cosecant alpha times cosecant beta. On the bottom, we have cosine beta over sine beta. That's cotangent beta. Minus cosine alpha over sine alpha is cotangent alpha. And indeed, that's what we were trying to get to. Okay, so this one was a little bit more complex, and we did have to think about like where we wanted to go. Another way that we could do this, which may be a little more straightforward for you, is to look at the numerators instead. So once we got to this step here where everything was in pink, multiply the top and bottom by cosecant alpha cosecant beta, and then simplify the denominator. Okay, that would also work. I chose to work with the denominators just as a matter of personal preference. Okay, so I have one last example I'd like to go through using one of our double angle formulas. Okay, and there are all sorts of variations on these problems. Some of them are straightforward, some of them are a little less straightforward. Most of them will employ not just the formulas from Unit 3, but also some of the fundamental basic formulas that we did in Unit 1. Okay, so let's suppose now we wanted to prove the identity cotangent 2 theta equals 1/2 secant theta cosecant theta minus tangent theta. Okay, so again, we're starting out with, if we look at the left-hand side, something we don't exactly have a formula for. Okay, so we don't have a formula for cotangent of 2 theta. But what we do have is a formula for tangent of 2 theta. Okay, so we can start by writing cotangent of 2 theta as 1 over the tangent of 2 theta using a reciprocal identity. Okay, and now we can use the double angle formula for tangent, which was 2 times the tangent of theta over 1 minus tangent squared theta. Okay, Okay, so really we're taking the reciprocal of 2 tan theta over 1 minus tan squared theta, and that's 1 minus tan squared theta over 2 tan theta. Okay, so just to recap, we first used a reciprocal identity to write tangent, or 1 over tangent as cotangent, and then we plugged in the double angle formula for tangent, and then we take the reciprocal to get the double angle formula for cotangent. Okay, so now we want to try to simplify this expression. So we want to think about some of the stuff we were doing at the beginning part of this unit when I talked about the techniques in the first 2 videos to prove identities. When we have fractions and when we have a sum or difference in the numerator, it often makes sense to break that fraction up. So if we do that, we're going to end up with 1 over 2 tan theta minus tan theta over 2. Okay, because we'd have 1 over 2 tan theta minus tan squared theta over 2 tan theta. And then we can cancel a tangent theta on the top and bottom. All right, so now we're getting close to where we need to go. So we need to handle this first term at some point. But note that we're pretty close with our second term. So we have a minus 1/2 tangent theta. We want a minus tangent theta. So that's going to be easy enough for us to manage. So we have, and I'm going to rewrite this first term here as right now 1/2 cotangent theta, just to make things a little bit nicer for us. And then we have, I'm going to leave a little bit of space here, so we have minus 1/2 tangent theta. And we want a minus 1 tangent theta. So I'm going to subtract another 1/2 tangent theta. Okay, so when we do that, we have our minus tangent theta. Okay, so that's what we wanted. But if we take something away in order to keep things equal, we have to add it as well. So what I'm doing is adding and subtracting 1/2 tan theta. So when we do that, in our second term, we have our minus tan theta, which is what we wanted. Over here, we have 1/2 cotangent theta plus 1/2 tangent theta. Okay, so now we want to try to simplify this. Okay, and there are a couple different ways to go about this. I'm going to use, since we have secants and cosecants, let's start writing things in terms of sine and cosine, and then we can combine fractions. Okay, so over here, we're going to have 1/2 cotangent theta is cosine theta over sine theta. Tangent theta is sine theta over cosine theta. Okay, so now we want to combine these fractions. So we want a common denominator of cosine theta sine theta. Okay, so we'll take our first term, multiply the top and bottom by cosine theta over cosine theta. Take our second term, multiply by sine theta over sine theta. Okay, so then what we end up with, all told, is cosine squared theta plus sine squared theta over 2 sine theta cosine theta. So that's our first term. So we have the 2 on the bottom, we have the sine theta and the cosine theta on the bottom. Then up top we'll have cosine squared plus sine squared. And then we have that minus tangent theta. And that's going to equal cosine squared theta plus sine squared theta is 1. So we have 1 over 2 sine theta cosine theta. We use the Pythagorean identity there, minus tan theta. Okay, and then finally, we're going to use our reciprocal identities, and we'll note that 1 over 2 sine theta cosine theta is the same thing as 1/2 secant theta cosecant theta. Okay, because 1/sin theta is cosecant, 1/cosine theta is secant. Okay, and that's exactly what we set out to prove. Okay, so that's a very much more complicated identity than the other ones that we had to prove. But again, what we did was all in the realm of feasibility. The biggest thing here, and this is not a technique that we use very often, but it helps sometimes. We noted the fact that we were subtracting 1/2 of a tangent theta. We wanted to subtract a full tangent theta, so what we can do is subtract another 1/2 and then add another 1/2, and that doesn't change our term because we're adding 0, but then we can combine the -1/2 to get a minus tangent theta. And we take the sum here and we combine them and show that they equal the 1/2 secant theta cosecant theta. Okay, so that's all for this video. I hope you found these techniques helpful.